Digital fabrication tools such as 3D printers, laser cutters, and prototyping electronics toolkits became largely available to hobbyists and more prevalent in industry in the early 2000s. They generated hopes for a decentralized, more sustainable industrial production, sometimes described as a new industrial revolution, and hopes of democratizing innovation through the establishment of makerspaces, envisioned as mini factories and places of apprenticeship. Yet, Fab Labs and hackerspaces have faced and face financial difficulties, as did other stakeholders in the field, such as Make Magazine. We must definitely not producing all of our household objects locally or more sustainably, and we've not all become makers. So while there can be domains and moments in which digital fabrication is useful, there is significant scope for exploration. Does digital fabrication change work beyond engineering-related professions? If so, how does it change organizations and workers or their relationships with other stakeholders? This is the broader context of our research, which investigates these issues through case studies of the uses of digital fabrication tools by workers over 6 years in an organization providing educational services to visually impaired children in France. Indeed, assistive technologies is one domain in which HCR researchers have embraced early the potential of digital fabrication. This research project hence aims at understanding long-term digital fabrication practices for the education of visually impaired youth. There is a wealth of previous work outlining the potential of digital fabrication in this context, which stemmed from hopes that digital fabrication could advantageously replace specialized tools and cut costs, that advances in 3D modeling tools could allow anyone to produce tactile representations or other assistive technologies, and that online libraries such as Thingiverse could become repositories of models seamlessly produced all around the world. Investigation into practices, however, suggests a different picture. We know from efforts to gather the community's opinions on the matter that we still have a lot to learn about designing accessible representations, and observational studies suggest that 3D printers are rapidly abandoned in special education schools. So we opted for looking at practices in depth, using an ethnographic approach and activity theory models as a framework to both understand how workers defined what digital fabrication tools can be used for through practices and how it changed the organization, for instance, the division of labor. We found strikingly different practices than what had been envisioned in previous work. For instance, in the 50 objects we analyzed, we found that while 3D representations are sometimes useful, they are of limited utility in pedagogy, and that 3D printing is far too limited in terms of tactile experience. As we observe digital fabrication tools in context, we realize that 3D modeling software are either too complex or too constrained, whereas laser cutting allows for a far more flexible way of envisioning and realizing accessible representations, in part because it allows for more direct interaction with materials. Meanwhile, these tools did not replace specialized equipment. Instead, they added to them and generated new costs. Workers did not become makers, even if they had a 3D printer and extensive support to use it. At the contrary, over time, fewer people engaged in making and very few developed in-depth expertise. Yet, awareness and proximity to digital fabrication processes did impact how workers felt involved in innovation, and they organized to obtain the resources necessary to develop these practices in their fields, such as supporting the creation of a national database of projects, as websites such as Thingiverse did not meet pedagogical needs. To conclude, we call for studying making for accessibility at smaller scales rather than as a global phenomena to understand how digital fabrication tools might be used differently depending on the national or even regional context, instead of hoping they will allow for seamless production. By doing this, we could bring workers and their organizations back in our studies of making, which previously largely focused on volunteers and self-driven individuals. It would furthermore allow us to move beyond a technology-driven focus on 3D printing to instead consider the role digital fabrication could play in larger socio-technical ecosystems providing visually impaired youth with adequate access to educational material. Thank you for listening, and please get in touch for questions or discussions.